Hello, I Dr. Vijay Chandra Jadala welcomes to today's session. Today I am going to discuss related to the networking services and edge services. So here networking services, the major service here provided by the networking in AWS is Amazon Route 53. It is a reliable, cost effective way to route end users related to the internet applications. It is expanded globally, whereas the root end users can cite reliably and globally. That means they can depend on it very confidently. So, as Amazon Route 53, end user can reliable on that particular service where it is dispersed domain name system, that is DNS servers and automatic scaling. Next comes to the setup of the DNS routing in the minutes with domain name registration and start forward visual traffic flow tools. Next comes to the customize your DNS route policies to reduce latency, improve application availability and maintain compliance. Here we can see the structure of the AWS 53, and here we can observe how it works. Here Amazon Route 53 is a highly available and scalable domain name system with web services. Route 53 connects user requests to internet applications running on AWS or on premises. So here the end user will be there. Majorly we focus on the end user, and the end user will be connected to the DNS resolver. Then it connects to the Amazon Route 53, where it will authenticate through the DNS service. Here the radius IP address for the particular DNS record is queried based on the DNS resolver. So here the health checks will be completed. Here the 4 different activities are going to be taken place. One is the AWS management console, another is the Amazon Route 53, that it will depend upon the SDK and API, where the customer interface is hosted on the zone creations and the traffic policies, and the proportion of the DNS will be identified and records at the Route 53 global network and will authenticate the DNS servers. Then this will be verified with the health checks, where it monitors the health of your endpoints for the high availability. Next comes to the AWS Cloud Watch, where it is monitors metric and algorithms where the endpoint instances will be identified. So here we discussed related to the Amazon Route 53 how it works. Then Amazon Route 53 is a highly available and scalable DNS system, that is the domain name system of the web services, and it routes the Amazon 53 connects user requests to the internet applications for running the Amazon web services. So next we are going to discuss the use cases of the Amazon Route 53, where it will manages the network traffic globally, and it will create, visualize and scale complex routing relationship between the records and policies with the easy to use global DNS features. Then comes to the build highly available applications, where it will set the policies to predetermined and automate responses in case of failures, like redirecting the traffic to alternate availability zones or regions. Then comes to the setup private DNS, where you are going to set the Amazon virtual private cloud, that is the VPC, where it use the internal AWS resources and servers without exposing the DNS data to the public internet. Then comes to the who are the customers for the Amazon Route 53, that is the McDonald's, Netflix and Slack, where the Netflix application resiliency with the Amazon Route 53, it increase the application resiliency, the Netflix because of the Amazon Route 53, whereas the Slack improved the API security and the performance with the Amazon Route 53, and McDonald's managed the global traffic routing with the Amazon Route 53. Next comes to the edge services. The edge services are the CloudFront, whereas the CloudFront which delivers the content through the World Wide Web. These network of the data centers are called the edge connections or edge locations, where all over the world the systems are connected to one and another through the data centers, and these data centers which are located all over the world is known as the edge locations, and the CloudFront delivers the content with the help of these edge locations. Whenever a user requests to the content that particular serving with the front end, the request is routed to the edge location that provides the lowest latency, that is the time delay, so that the content is delivered with the best possible performance. So, this is all about the edge services, that is the CloudFront. Next is the network connectivity and the backbone. So, here the CloudFront has the network connectivity as well as the backbone. So, Amazon CloudFront pairs with thousands of network telecommunication networks, which is are of first tier, tier 1, tier 2 and tier 3, where it carries the globally well connected with all major access networks for optimal performance, and has hundreds of terabytes of the deployed capacity. So, here the CloudFront edge locations are connected to the AWS regions through the AWS network backbone, fully redundant, that is about the 100 GBE parallel fiber will be used with the global networks of networks. So, it is going to fetch different networks as they are of the different dynamic acceleration points. Next comes to the, here in this figure you can observe what are the edge locations, what are the multiple edge locations, what are the regional edge caches. So, here the circles all over the world is the blue color, you can identify them as the edge locations, and with the violet color you can identify them as the multiple edge locations, and with the orange color you can identify it as the regional edge cache. Next comes to the edge services, that is the global accelerator, which improves acceleration, availability, performance and security using the AWS global network. So, the improvement of this network performing is around the 60% related to the application delivery, whereas the delivery is available for the different applications with fast failover for multi-region and multi-AZ architectures. Achieve deterministic routing by removing DNS cache dependencies. Then comes to the protect your application from DDoS attack. So, the different attacks, where the DDoS attack is the attack where the continuous flow of the data will be stored the services, so that the data cannot be go further, the edge service cannot be go further. So, here the global accelerator provides the service to protect this particular DDoS attack. Now, let us see the edge services, that is the global accelerator, and how does this particular global accelerator works. This global accelerator depends upon, can be accumulate the different regions and it can work. So, it can use up to 10 regions. Here we taken an example of only 3 regions, that is the region 1, region 2 and region 3. Region 3 we have the Amazon EC2, region 2 we have application load balancer, and region 1 we have the network load balancer. So, here end user requests the AWS global accelerator to connect with the regions. So, it can connect up to 10 regions through globally. Once it connected, from these regions the different applications can be activated. Example, in region 3 we activated the Amazon EC2 in region 2, we activated the application load balancer in region 1, we activated the network load balancer. So that AWS Accelerator, AWS Global Accelerator is a network services that helps to improve the availability, performance and security to your public applications. So the global accelerator provides two global static public IPs that acts as fixed entry points to the application endpoints such as application load balancers, network load balancers, Amazon Elastic Compute Cloud, that is EC2 instances, and Elastic IPs. Next comes to the AWS Global Accelerator, that is use cases. Those are the Global Traffic Manager, API Acceleration, Global Static IP, Low Latency Gaming and Media Workloads. So here the Global Traffic Manager, which uses the traffic deals to related to the route traffic, the nearest region or the archive, the fast failover across the regions. Then comes to the Accelerate API, works by 60% leveraging the TCP termination at particular edge. Then comes to the Global Static IP, that is simplify low listing in the enterprise firewalling and IoT use cases. Then comes to the use custom routing to deterministically route the traffic to fleet of the EC2 instances. Next comes to the network connectivity options, that is VPN, virtual private network. So here the AWS network connectivity options are AWS site to site VPN, AWS transit gateway plus AWS site to site VPN, AWS Direct Connect, AWS Direct Connect plus AWS transit gateway. Next comes the AWS Direct Connect plus AWS site to site VPN, AWS Direct Connect plus AWS transit gateway plus AWS site to site VPN, AWS VPN Cloud Hub, AWS transit gateway plus SD-WAN solution. Then comes to the software VPN. Next comes to the network connectivity options, that is the Direct Connect. So the Direct Connect, it comes under the VPC, virtual private cloud. Then comes to the, it depends upon the region and AWS cloud. So here the availability zone A is Amazon EC2. Then comes to the availability zone B is also two sets of private subnets are used for the virtual private gateway. And then comes to the phone VF, where it is AWS Direct Connect location, that is connect to the Direct Connect location and the connect locations, which determines to the AWS Direct Connect. And then comes to the customer gateway, where it is customer network, that is the client and client will be connected to the server. So here the AWS Direct Connect makes it easy to establish a directed connection from on-premises network to one or more virtual private clouds. AWS Direct Connect can reduce network costs, increase bandwidth throughput and provide a more consistent network experiences than internet based connections. It uses industry standards 802.1q VLANs which are connected to the Amazon VPC, which uses the private IP address. The VLAN are configured using the virtual interfaces. By this I am concluding today's session. Thank you one and all.